Hey, it's Caleb. If you like this video, be sure to subscribe. Hey everyone, thank you for sticking with me this far. In this video, I just want to do a little bit of review as well as go over the vocabulary that we've learned. So if you don't really want to know, we're going to go over some new ones too, but if you don't want to review, then feel free to skip this video and the next one. So this video will be about data and database design terms. So the very first term we learned was data. Data is pretty much anything we store in a database. You pretty much know what that is, so that one's pretty good. Database, that is what we store our data in. And then we have a specific kind of database, which is a relational database. And what's special about a relational database is that it stores things in tables. We have a database management system, or database managed, DBMS for short. That is how we manage a database using code. That's how we control our database. We have a specific kind of database management system called a relational database management system, which is just used to control our tables and the values within our tables of a relational database. Pretty simple. Now we're going to introduce a new word to you, which is null, or null, however you want to pronounce it. I've been told I pronounce it wrong, but I don't really care. Anyways, this is when someone does not enter a value within a column on a table. So if we have a table, and we have something such as fax number. Well, not everyone is going to have a fax number. So when we have a guy, let's say we have an ID here, we have a guy with the ID of 7, and we don't have a fax number, this emptiness is said to be null. So basically, you'll hear empty value, although by definition, null means no value, so it's kind of a bad definition, but who cares? Null basically means there is no data in that specific field. And we'll be getting into more terms like that in a second. So that is what null means. That's one you will need to know. Another one is an anomaly, or anomalies. So, anomalies are basically errors within our data our data integrity. So when we have an anomaly, it's something that goes away from what we expect or from the normal. When we update something, for example, and instead of updating one column, it updates 10 and it wasn't supposed to, that's an anomaly. So yeah, you'll need to know that as well. The other one is integrity. We implement database integrity to protect against anomalies. So we went over 3 different kinds of integrity. We went over entity integrity, we went over referential, and we went over domain. Real quick what these are. Entity integrity is saying uniqueness among the table. Referential keeps the connections, the keys, foreign keys, primary keys, they keep them connected across multiple tables. So we could say these 2 tables have some kind of connection. And then domain is basically saying a column within a table has all of the expected values. So we have a phone number, we would expect numbers, not text, or not a date. That is domain integrity. And the word domain is basically the range of values that are acceptable to store within a column. So these are our data vocabulary that you should know. Now we're going to move on into the design terms. Yay. Okay. So designing is what we're here for, so this is fun. Very first thing you need to know is an entity. which is anything we store data about. A user, a mortgage, a transaction, a credit card information. Anything, the comments, a comment, they're all entities. It's what we're storing data about. Then we have attributes. Attributes are the things we store about the entity. A comment, an attribute of a comment would be the date that it was made. The length, how many characters is it? Who posted it? That's an example of an attribute. A relation, if we're talking about mathematics, it's a connection between two sets of data. When we're talking about databasing, put very simply, it's just a table. So a relation is another name for a table, where we have data within our database. So we can have a structure of different tables. So these can be connected. Just, I don't know, however you want to connect them. This can be our database. Well, each one of these different sets of information or data is known as a relation. It's a table. Next term is a tuple, however you want to pronounce that too. Just winging it here. That's another thing for a row. It's all of the attributes about a specific entity. So if we have this guy, we can say his name is Caleb. His phone number is blah 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 blah. His address, his age, his birth date would probably be better. How long he's been a member of this website or whatever it is. All of these values about this entity, that's what that is, a tuple. That would also be a row on a table, because we physically represent relations with a table. So when we have a table, we have the columns, so we have name, phone number, address, social security number, and then when we enter all of those for a specific person, we have the ID of 7, the name Caleb, the phone number, blah blah blah, the address, blah blah blah. That is known as a tuple or a row. Another term is a table, which we just talked about that, which is just a physical representation of a relation. Tables are what we store in a database to organize. Am I like cutting my head off there? Can't really see. To organize our data. Within a table, we have rows and we have columns. The rows would be a specific individual entry within our table. So like that guy we just drew, all of his values would be his row. The columns are that specific, a specific attribute of that person, such as a name. This is the column where we would put the value Caleb. Alright, now we also have another three more terms that we haven't learned yet, which you will possibly hear. They're kind of older terms, but they're just talking about the same thing. You may hear the terms file, record, and then field. So what are these talking about? Well, file is just another name for a table. A record is another name for a row, and a field is another term for a column. So other than that, we have the words value. A value is the information that we put in to a specific column. So here is a value, Caleb, or subscribe, or or 700, or June 16th, whatever it is. Those are all values. Alright. Oh man, it's already 10 minutes. Dang. Alright, then we have an entry. You may hear the term entry, which I like to use this for it's almost like a verb. When you enter data, you get an entry. So basically an entry is just another name for a row. So there's obviously a lot of similar names, and we'll be making a table saying what word. Just give me a minute. Database design. The process of designing your table to remove anomalies and have data integrity. Schema, however you want to pronounce that, that is just a drawn out structure of our database. Then we have a new term here. It's called normalize or normalization. Normalization is basically just a bunch of steps that we're going to follow to help us get the best database design. So that's part of database design when we go through these normal forms to get the best database design. We'll talk about that more in an upcoming video, but I want you to know that the term normalization is the process of building the best database design. The other one, naming conventions. A naming convention is just a consistency used to make things consistent. So we name tables a certain way, we name columns a certain way, we name our database a certain way, we draw our database schema a certain way. So basically, convention is anything that is done repeatedly to create consistency. And the last one here is keys, which I'm not sure if I talked about this or not yet. I think a little bit, but not much. A key is something to make everything unique within a table. This is how we make connections among tables. We connect IDs. We may say, oh, this comment was posted by the user with the ID of 7. Well, that points back to the user table. We do all of that with keys, and we'll learn more about those as time goes on. Alright, so you see we have a lot of terms, and a lot of them are repeats for this meaning the same thing. For example, we have a relation, and then we have table, and then we have file. So relation, table, and file are all talking about the physical structure, a table, pretty much. Record, I'm going to circle these ones. Record would be a row, so we have a row, and then we have a tuple. These are all talking about rows within a table. And then we have, how should I do this? Let's cross them out. We have columns, and then we have attributes, and then we have a field. Those are all talking about a column in a table. And also entry, you can kind of think of that as a row, because you enter data into the table and you get a new row. A value is just a specific, you can think of it like, let me erase some of this. We have this table and we break it up into columns. So we have ID, name, and then phone number, for example. Those are our column headers, and then we have specific values. 7, Caleb, and then we have another guy, 8. Well, if we separate this into cells, which is another term, we have a specific value that we put in here, such as John. That is a value. Now, entity, that's the only one that's so we just went over value. Entity is what's left that's not circled or crossed out or squared or something. Entity is, I don't like to really assign this to like a row or a table or anything, because an entity is just something we're storing data about. So that could be an individual row, or it could be the table type. So for example, we have a table for users. Well, the user is the entity, but a specific entity would be a row within this table, because we'd have the entity for this guy over here, and then we'd have one for this guy down here, or for this chick over here, or lady, I should say. So these all get their own rows, you see? So an entity, that's just something we store data about. So yeah, I know that was super long, and hopefully that was helpful, and if I just was rambling on, I'm sorry. But I'll see you in the next video. Be sure to subscribe.